Hello everyone, welcome back to the channel. In this video, we will learn about LangGraph, its core concepts, various aspects of LangGraph, and then we'll also see a use case, basically a content generation use case using LangGraph and various functionalities in LangGraph. So we'll first of all we'll start off with the basic concepts, and then we'll move on to the project. To start, LangGraph is developed by LangChain, and it is a framework that enables the construction of stateful graph-based workflows for AI-driven applications. Now we'll see what is stateful and what is graph-based. So LangGraph facilitates the creation of structured, modular, and scalable AI workflows by leveraging graph-based processing. This approach provides greater control, adaptability, and efficiency compared to traditional linear pipelines. Now we'll see the core concepts of LangGraph. So first of all, we'll see state. So what is a state? So the state represents the shared context across different nodes. So the state basically enables us to use the variables and the values on the variables across different nodes in the entire workflow. It can be implemented using Python types such as typedict or pydantic base model. State allows information to persist across different steps in the workflow. So we can have the values of the variables stored in the state, which can be used in various nodes, in a particular workflow. Then we have nodes. So nodes are basically functions that perform specific tasks within the graph. Each node receives state as input, processes it, and returns an updated state. The node can represent a variety of AI operations, including LLM interactions, data transformations, or API calls. So a node can be anything. A node can be a LLM call. It can be an API call, or it can be a simple function. It can be a data transformation function, right? So any function, we can call it as a node, to summarize. Then we have edges. So edges define execution flow by determining how nodes transition between different states. So these edges basically are the connectivity between the different nodes, right? So we connect different nodes using these edges. We'll also see a diagram in which we'll see what is the meaning of nodes and edges practically. So these edges can be simple linear connections or conditional branches. There's a concept of conditional edges also that introduce decision making capabilities. So LangGraph provides the flexibility to model dynamic workflows, making it ideal for multi-agent applications, conversational AI, and structured content generation, right? So it can be used for various purposes. Now we'll see graph versus state graph. So this LangGraph particularly has two different classes to create or implement a workflow. First is the graph and second is the state graph. Mostly we use state graph, but for this particular tutorial in this video we'll be using graph to start off with, because graph is slightly simpler than state graph. So we'll start from basics, and in the next video we'll see what is the state graph, right? So graphs in LangGraph basically define execution flows. Both of these define execution flows. But state graph is an enhanced version that incorporates state management. So state graph has a concept called as state management, right? We'll see what is state management. So LangChain provides two primary execution models, right? First is graph, second one is state graph. So we have these two execution models available as two different classes in LangChain. So each serving different use case based on workflow complexity and state management requirements, right? So a graph in LangGraph is a straightforward execution structure where nodes are connected by edges, right? Defining a sequential or conditional flow of execution. However, it does not inherently maintain a shared state. So a simple graph class does not have a shared state inherently, right? By default, it doesn't have a shared state. And we already know what is the state from here, right? So meaning each node functions independently, processing inputs and producing outputs without persistent data across executions. So there is no concept of state here in the graph class, right? This makes it ideal for simple routing, static workflows, and task sequencing where context retention is not required. So where we do not need states, basically the variables whose values we need to pass on to different nodes one after the other. In those scenarios, we can go with a simple graph. right? On the other hand, state graph extends the graph model by incorporating stateful execution, where nodes can modify and retain a shared state throughout the workflow, right? So all the various nodes in the workflow can access the state or the variables present in the state, right, throughout the workflow. This allows for dynamic decision making, enabling the workflow to adapt based on intermediate results, right? So we'll in state graph, basically the intermediate results are available across across the various nodes inside that workflow. State graph is particularly useful for complex AI-driven applications such as multi-turn conversations, iterative LLM processing, and multi-agent coordination, where maintaining context is crucial, right? The context is crucial. So whenever context is crucial, whenever we have to retain the context from the previous calls, right? So in that case, we need to maintain a state, and in that state, we'll maintain all those previous conversations, all those previous context. So in those scenarios, state graph is important, or state graph should be used. So usually we go with state graph, but for the purpose of this video, we'll first see the graph example here. In the next video, we'll see what is a state graph, and we'll in detail we'll see a project where we'll be using state graph, right? So in summary, graph is suited for simpler stateless workflows, while state graph is essential for stateful multi-step processes where which requires context retention and real-time state updates, right? So now we'll see the sample project, a sample content generation project, where we'll be having two different functions. The first function will be generating the content. The second function will be summarizing the content into 5 bullet points. So when I say functions, we can also call it nodes. So we'll be having two different nodes. The first node will be the article generator node. The second node will be the summarization node, right? So before we start, we can just install the required packages: pip install LangGraph, LangChain, Pydantic, LangChain community, right? And then we can import the chat models, chat olama from LangChain community, right? And then we are using the olama Mistral model here, basically. So this is the first node, which is the generate article node. It takes the input, and then the prompt is write an article on the given topic, right? So this takes as a input here, this input basically, and then it invokes, and we get the response here. Now this create summary is the second node, where it summarizes the article which comes from the previous node in 5 points, right? And then it invokes the LLM. The LLM is the Mistral model from Olama, right? And then we'll create the graph, basically. So first of all, we'll create the object of this graph class, right? So graph is equal to graph. This is the class name, and then we'll start adding the nodes. So we first of all we'll add the first node, which is the generate article node. So this is the name of the node basically in the codes, and this is the function name. This function name can be anything, and this so these two need not be same. The name of the function and the name of the node need not be same. So whatever we name it here, that we'll be able to see in the actual graph or actual picture of the workflow, right? So the first node name is generate article node, and the function is generate article, this particular function. The second node is create summary node, and the function we are using is create summary function here, right? And then we are creating the edge between these two nodes, right? So we'll say graph dot add edge, and we'll mention the two nodes between which we want to create the edge. Edge is nothing but the connectivity between these two nodes. Now we'll set the entry point, basically from where we will the point at which we'll give the input, in this workflow. The entry point is generate article. The first function is the entry point, right? And then the finish point is basically the create summary function, right? Where we'll get the final output. This is the finish point, so we'll call graph dot set finish point is create summary. Now we'll compile this graph. So now we'll start running these block of codes one by one. So first of all, we'll run this first node. We'll create the first node, and then we'll create the second node, and then we'll add the nodes and add the edge, right? And then we'll set the entry point, and then we'll set the finish point, and then finally we are ready to compile our graph. So the compilation is done, and now we are ready to invoke. So here we'll say app dot invoke LangChain, right? So this input is going to go straight away here, right? And from here this will go to this prompt, write an article on the top on the given topic LangChain, and then it will invoke, right? It'll invoke this particular function, right? So now we are ready to invoke this. So we'll just say run. It might take a few seconds here before we get the output. right? So till then we'll see the flow, right? So once I give the input as LangChain here, it generates the article. Now since we have connected the edge between these two nodes, so the output of this one will be taken as input in the next node, which is the create summary node, right? And then based on the article, once it gets the article, it will generate the summary in basically 5 bullet points, right? So this is the purpose of adding the edge here between the two nodes. So this edge basically serves as the connectivity between two nodes, right? So the output of the first node will go as the input in the second node, right? Because we have an edge connectivity between these two nodes basically, right? So now it is still running. It might take a few more seconds before we see the output. Okay, so we'll wait for a few more seconds. And then at the end of this, we'll also see a diagram of this workflow basically. That will make it more clear to understand. Okay, so it's taking some time. We'll wait for a few more seconds. Okay, we're still waiting. So this takes a few seconds, based on based on your laptop, on your system, right? This might take a few seconds. This execution basically, right? So, okay, we'll wait for a few more seconds and then we'll see the output. It's taking some time. Okay, so here we have the output, the summary. This article, the title of the article is Leveraging Language Models for Efficient Communication and Collaboration, an Introduction to LangChain. Okay, now we can also see the step-by-step execution here, basically the output at each node, right? So we'll here set the input as a variable, we'll say LangChain as the input, and then we'll run this particular piece of code to get the a step-by-step execution or step-by-step output at each node. So this might again take a few seconds. So I'll be putting this code inside the GitHub, GitHub repository. So you can access this code and you can play around with this. You can tweak this and you can use it to create some other project based on your requirement, or you can use it for learning purposes, right? So you'll be having the access to the code on the GitHub basically. So the output from the first node, which is generate article node, is this one. The article is titled Exploring the Future of Language Translation with LangChain, right? And then you'll see the output of the second node. And the output from the second node, which is the create summary node, is again the title is the same, which we have, and then we have a basically summary, a 5 point summary here, right? 5 bullet points are here, right? So now this is all. Now we'll see the actual diagram of the workflow. So this is the actual diagram of the workflow where this first of all we have the start node here, and then we have the generate article node, then create summary, and then end. And this so basically these are the nodes: generate article, create summary. These are two nodes which we created, and the connectivity between this, right? This is the edge, which connects these two nodes. So the output of this particular node is taken as the input in this particular node, right? Because of this edge connectivity over here, right? So This is all for this video. In the next video, I'll be putting, I'll be putting a video on state graph and few other important topics in LangGraph, right? So, and I'll be creating a playlist basically on LangGraph, right, where I'll try to cover each and every aspect of LangGraph. I'll be giving various projects, various use cases, right, on different aspects. So I'll be covering both the theoretical part of each and every aspect of LangGraph and a sample or basically a use case, based on that particular concept or that particular aspect, right? So keep watching the channel. If you really like the content, subscribe the channel, like the video, share the video with your friends so that maximum people can benefit from the content. I'll see you soon in the next video. Till then, thank you for watching the video. Thank you.